Hello students, good morning. Let us start the class now. In the last classes we have been discussing about the properties of information. Today we will go a little more about discussing the accurate properties of an information. So please recall, what is information? Information is that which is not known. Knowledge is the one which is known. Okay. So let me read out. The discrete information source emits messages at intervals, each message consisting of a sequence of symbols. As you already know, we send messages as sequence of characters or symbols, and each symbol is nothing but a collection of bits. For each symbol, a certain set of bits are allocated, and the symbols comprise of sequences, and we send sequences as information. So always in information theory we deal with discrete information sources. We don't deal with analog sources. If at all there are analog sources, that analog information has to be converted into digital form or discrete form. So if an analog voice is there, that voice has to be converted into discrete samples, and the samples are going to be digitized again. Otherwise, in most of the digital systems, the information is always discrete in nature. So discrete information source emits messages at intervals, each message consisting of a sequence of symbols. All messages do not contain the same amount of information. Now, the less probable messages convey more amount of information. This is important. The less probable messages convey more amount of information. How? Sun rises in the east is not an information because it is known, it is knowledge. Sun rises in the west is also not an information because sun sets in the west is a fact which is known. Sun rises in the west is observed. So sun rises in the east is not an information as such. Sun rises in the west is also not an information. Sun rises in the west is observed. Sun rises in the east is knowledge, which means the probability of sun rising in the east is 1, and the probability of sun rising in the west is 0, which means the one information for which the probability is 1, it does not contain more information. Sun rising in the east is having a probability of 1, it is always 100%. That means it is not conveying a large amount of information. Now sun rising in the west is probability 0 and it is observed, and that is also not an information. Now what is an information then? Whichever is having higher probability contains less amount of information. Whichever is having lesser probability is containing more amount of information. Now what does it mean? Corona count is increasing day by day. Now this corona count is increasing day by day. Now this is not an information because it is having a higher probability. In fact, in India it is much better. In US it is much worse because in India at least people are following the norms. In USA people are not following the norms. 2 weeks before, my one ex-student from USA, he made me a call and I asked him how is the situation in USA. He says in USA the situation is worst. In the Florida beach, people are wandering like anything and they keep on touching every object. They don't wear masks also. They are so careless. Which means in America the number of cases increasing is not an information because its probability is more. Now, let us say in some country, let us say China. In China, people followed all the norms because there is a communist government there. People follow all the rules of the government. Now, in China, the number of corona cases reducing is also not an information. Why? The probability of people following the norms there is also more there. Okay. Now, what is an information? The information which is carrying lesser probability is having a higher amount of information. For example, Arvind sir taking a class now from 11:10 to 12:10 is not an information as such, because it is already planned in the timetable. So it is highly probable that Arvinda will take the class. Now third hour class is going on. Now today there is again a fifth hour class. For the fifth hour class also, Arvinda is going to take the class in the fifth hour is not again an information which is containing a large amount. Reason is it is defined in the timetable. Now let us say something else happens in the department now, some emergency occurs maybe in the department or in the institution. Now let us say Arvinda sir is unable to take class in the fifth hour. Now that will make students happy now. Okay. Happy or sad, I don't know. Now, if at all, what is the probability of me taking class in fifth hour? There is a high probability. High probability is less information. Now, what is the probability that I will not take class in the fifth hour due to some other emergency occurring? Maybe I postpone the class, or maybe I take class tomorrow. If that is the case, then what is the information which you receive in the fifth hour instead of me if some other faculty member is going to take the class? Instead of me in the fifth hour, my class is engaged by some other faculty member. Now that is an information because it is having lesser probability. The one which is having lesser probability is containing higher amount of information. In general, people talk only those things which are less probable. For example, traffic jam in Bengaluru was not an information 4-5 months before or 6 months before. Now, almost all the roads in Bengaluru city are not really heavily crowded. There is not much of a traffic jam. Let us say today traffic jam happening in Marathalli area is an information because it is less probable. Maybe after about 6 months, when we have offline, then again traffic increases. When traffic increases, again traffic jam occurring in Bangalore is not an information because it is common. Traffic jam not occurring when people start moving again after the offline classes start, then that can be an information. So, you please understand this. The less probable messages convey more amount of information. Whichever is having lesser probability, only that thing people are going to talk more. Whatever people are going to talk more or convey more, that is going to contain more amount of information. So, the goal here is we want to measure the amount of information. When we measure the amount of information, we want to find out the efficiency of the communication. In technicality or in technology, for everything, there is an outcome required. There is an outcome expected. So, in technology, we want to measure the quality of communication that is happening. For the quality of communication that is happening, we have to characterize the channel. For characterizing the channel, we have to know how much of information is flowing through the channel. So, always remember this, the less probable messages convey more amount of information. This means that the uncertain events are more informative than the certainly occurring events. The uncertain events have lesser probability. They are more informative than the certainly occurring events. In other words, the more predictable events contain less information than the less predictable ones. For example, message about an eclipse. Message about an eclipse is more informative than the message about a new moon day. Just a minute, I'll have to put a signature here for the exam document. I am muting myself. Okay, let me resume. The message about an eclipse is more informative than the message about a new moon day. Why? New moon day is already known. It is already predefined as a calculation and it is available in the calendar as well. So we will be approximately knowing which is the date of new moon day or which is the date of full moon day. But we may not be exactly knowing an eclipse. Okay. New moon day, full moon day occur every month. Eclipse does not occur always. That means information about an eclipse is having more amount compared to the information about a new moon day. Further, the message about new moon day is more informative than the message about nightfall. Every day night is happening, every day is happening. That is not an information again. But a new moon day is happening once in a month. So, eclipse is having a highest amount of information when compared to new moon day. New moon day is containing a more amount of information when compared to nightfall. This means to say that information is the measure of the unknown details rather than about the known things. Again, remember this. Whatever is known is not an information. Whatever is unknown is an information. Which means information is the measure of the unknown details rather than about the known things. People will not talk about any known things. If at all you tell about any known thing to somebody that today after about 6 o'clock sunset is going to happen, then they will call you mad. Because they say already it is known. Why are you telling that? But if at all you say on some other day in the month of September, let us say an eclipse is happening. If you tell that way, then people will ask you which particular day, what time, daytime or night time, they are going to ask you. Which means information is the measure of the unknown details rather than about the known things. Another example is the toss of a fair coin. The toss of a fair coin contains more information than the toss of an uneven coin, because the toss of an uneven coin is more predictable than the fair coin. For example, let us say we have a coin, head side and tail side are equally polished. Imagine that way. There is no uneven surface. Imagine. Now when you toss that coin, head occurring or tail occurring is 1/2. It is always 50% if the coin is fair. Let us say the coin is slightly damaged or there is a bump somewhere on one surface and the polishing is not proper, then we can always predict that the heavier side will fall down. Whenever the heavier side or the uneven side or the rough surface, let us say it is falling down, when we toss it, then the tossing of the coin can be predicted. If the head surface is having an uneven surface or if it is a heavier side, when we toss it, it will come down that way and we can say that the probability of head occurring is more. That way, tossing of a fair coin contains more information than the tossing of an uneven coin, because in case of an uneven coin, it can be predicted. Now, based on this, we have this expression. The expression is I of m is proportional to 1 over p. This m is the message. I of m is the information contained in the message. And p is probability of the message. Okay. When the probability is less, information is more. This we have discussed in detail. So we can come to a conclusion. I of s is proportional to 1 over p, or I of s is inversely proportional to p. This is one property of information. Let us see the next properties as such. The absolutely certain events do not contain any information. For example, sun rising in the east is not an information at all. Now see, I of m is also called as self-information. We are going to discuss two things later on called self-information and mutual information. Self-information means information which is independent, which means it is not dependent on the next sequence. Okay. Always we send information by means of sequences. Sequences contain symbols. Symbols contain bits. Now these sequences, if they are unrelated, then we say that they are statistically independent. If they are statistically independent, then each sequence will contain its own self-information. But in reality, always we will have statistical dependency. That we will see later on. So I of m is called as self-information because the information that is independent and information is not dependent on the other sequences. I of m is 0 if p is 1. I have told already. If the probability of the event is 1, information contained is 0. That means sun rising in the east does not contain any information. I of m cannot be negative. Information can never be negative. When we measure information, we should measure it as a positive number. We are going to measure information in terms of the number now, because anything and everything is measurable nowadays. But this cannot be negative. Why? How can there be a negative information? Now today, 5th hour, Arvind sir may not take class because of some emergency. If that information comes to you, now that can never be a negative information as such. It cannot be labeled as -12 or -15 or -18. Any information has to be represented as a positive number. So information cannot be negative. But the information's effect may happen something negative. For example, somebody may tell some gossip about somebody else, or somebody may tell something wrong about somebody else. That may affect life as such. But that is the effect of the information. It is not the content of the information. Information cannot be negative. If at all you have any questions in between, you can always put it in the chat box. I will periodically keep checking the chat box. Now let us see. If M1, M2, up to MQ are the possible messages from an information source with the probabilities of occurrence of P1, P2 up to PQ. See, let us say the information source is going to emit discrete sequences. Now the discrete sequences, let us say we call them as messages. Now let us say you are going to send WhatsApp messages to your friends. Now you are going to send these sequences discretely. You are going to send first message, then second message, then third message, like that it goes on. Let us say first message is M1, second is M2, like that till the end of the day. Before you sleep, let us say you send up to Q messages. Now let us say that the probability of occurrence of each of these messages is P1, P2 up to PQ. Message M1 will contain a probability P1. Message M2 will contain a probability P2. For example, if you send a message to your friend saying whether lunch is over, what is the probability of you sending a message to your friend? That depends on your particular messaging behavior. What all messages generally people send to others, it is basically based on their own nature and behavior. So, on a teacher's day, a student sending a message to a teacher as happy teacher's day, what is the probability? That probability is nearly 80% to 90%, provided the student wants to greet the teacher on that day. Okay. So this way, for each message, we can have a, I have to keep admitting people as they keep waiting in the lobby. Students have to join in time, otherwise this meeting gets locked after some time. Let me continue. For each message, we can have a certain probability. Now we can add all these probability equal to 1, which means the time when you wake up till you sleep, you are going to send messages. As long as you have WhatsApp, as long as you have mobile phone, and especially adolescent age, in general you will send messages. Now the total probability will be equal to 1, means all the probabilities added together is unity, because that is a certainty. Now let us say for message M1 it is P1, for M2 it is P2, and P1 plus P2 plus till PQ is equal to 1. Then I of Mk is greater than I of Mj if Pk is less than Pj. This we have discussed already. Information contained in the message is larger if the probability is lesser. Means if the probability of Mk is lesser than the probability of Mj, then the I of Mk is greater than I of Mj. As we know, I of M is inversely proportional to P. So this is the first property of information. Now the second property, I of Mk tends to 0 as Pk tends to 1. If at all probability is tending to certainty, if a message is completely 1, then the information content is 0. I have given the example of sun rising in the east. Sun rising in the east, its probability is 1. So its information content is 0. This is the second property. Now the third property, I of mk is greater than or equal to 0 when pk is in between 0 and 1. Always I of mk is a positive number. Why? It is always proportional to 1 over p, and that p is also a positive number. Probability is a positive number, so information content also has to be positive. It cannot be negative. Probability cannot be a negative number. So when the probability is in between 0 and 1, 1 is certainty, 0 is impossible. In between them, in between impossible and certain, there is this uncertainty. Uncertainty itself is this pk. Absolutely possible events are having probability 1. Impossible events are having probability 0. All other events are going to come in between 0 and 1. So as it is inversely proportional, I of mk is greater than or equal to 0 when p of k is between 0 and 1. That means I of mk cannot be less than 0. Now if you observe all these three, what can we infer or what can we conclude? By observing all these three, we can conclude that the relation stated above indicate the logarithmic function. Now this is applicable to the logarithmic function. All these properties, these three properties are applicable to the logarithmic function. So we can write the measure of information as I of mk is log of 1 over pk. We can directly write that information content is equal to log of 1 over the probability. We already know that I of m is proportional to 1 over p. Now that proportionality should go, equality should come. So this is how we can define that I of mk is log of 1 over pk. The reason is all these three properties are applicable to logarithmic function. Or I of mk is minus of log of pk, because 1 over pk you can make it as a minus number. Again, don't think that I of mk will become negative. I of mk will not become negative. It is minus of log of pk. Okay. So the base of the logarithm decides the unit assigned to the information content. Whether we go for a natural logarithm, whether we go for a common logarithm, or whether we go for a binary logarithm. Whether we go to log to the base e, or whether we go to log to the base 10, or whether we go to log to the base 2. Log to the base 2 is also important because we are going to transmit binary information. We are going to transmit digital information. So we should define a unit for this. It is not actually we defining. They have already defined. Claude Shannon has been doing the phenomenal work. He had done the phenomenal work in the information theory. So the base of the logarithm decides the unit assigned to the information content. The unit is nat and decit for natural and common logarithms respectively. Nat is used for natural logarithm. Decit is used for common logarithm. This decit is also called as Hartley, to honor the scientist Hartley. Okay. Sometimes decit is called as Hartley. If the base is 2, then the unit is bit itself. Why? Because we are going log to the base 2. Now, if m1 and m2 are two independent messages, imagine they are statistically independent, they are not relevant to each other or not related to each other. Then the received total information content I of m1 and m2. Let us say you received two WhatsApp messages, first message and second message. Now that is equivalent to I of m1 into m2, because this is a logarithmic function. So I of m1 and m2 is I of m1 into m2, or I of m1 and m2 is equal to log of 1 over p1 into p2. Now the log of 1 over p1 into p2 is nothing but log of 1 over p1 plus log of 1 over p2. This is nothing but I of m1 plus I of m2. How? Because this became logarithmic function. whenever a product is there, the product in case of log is going to become a sum. That way, whenever you have two independent message that you are receiving, the net information content can be measured as I of M1 plus I of M2, because I of M1 is nothing but log of 1 over P1. I of M2 is nothing but log of 1 over P2. You have to remember this, because based on this we are going to work out some exercises. For example, let us say M1 is the scientist discovered a cure for a common cold. M2 is evidence of life was found on Mars. Now these two are statistically independent. The scientist discovering a cure for a common cold is not related to the evidence of life found on Mars. Both are done by scientists only, but these are two different scientists who are doing this work. And the work which is done for a medical reason and the work which is done for astronomical reason are not directly related as such. So we can say M1 and M2 are statistically independent. When they are statistically independent, the total information content is I of M1 plus I of M2. If they are statistically dependent, then we have to deal with this in a different way. Okay. That is why I told about self-information. Later on, we will have mutual information. Let us say two messages are related to each other, then there is something called mutual information. Then we have to measure it in a different way. The source is called as memoryless. This is a note. The source is called as memoryless if the symbols emitted are statistically independent of one another. Now we have an information source. For example, when you type the message into the WhatsApp, your mobile phone itself is the information source. Now let us say the symbols emitted from that, if they are statistically independent, then we can say that the source is memoryless. But in general, all the information sources that we use are containing symbols which are statistically dependent many times. In your WhatsApp message, when you have a chat, in the chat, so many messages are related to each other. Because there will be one question, one answer, one question, one answer, like that it goes on. Even when you converse with your friends, there can be so many messages in the WhatsApp, they are related to each other. That way, we cannot say that your WhatsApp information source is memoryless. It is having memory because the information is dependent on the previous message. So as such in our life, we don't have memoryless sources as such. Most of the information sources that we use nowadays are having memory. Actually, they are having digital memory as well. Even laptop is having a memory, and even mobile phone is having a memory. Everything is having a memory. But here, whenever we refer to memoryless, it does not mean to that physical memory. It does not mean to that RAM or flash. It does not mean to that particular memory. Please understand. We are not referring to the electronic memory here. We are referring to the source, which whether it is having memory of the previous event or not. For example, all normal human beings are not memoryless sources, because we have memory of yesterday, we have memory of day before yesterday. I can give an example that almost all insane people or mad people, they are memoryless sources. That way I can say, because a mad person or an insane person, he will not remember what he talked yesterday, what he talked the day before yesterday. Whatever he talks is going to be observed. His behavior will be observed. In such a case, we can say that that particular information source is memoryless. Otherwise, in general, all the sources are having memory. There the symbols are statistically dependent. Let us solve an example now, quickly. A card is drawn from a deck of playing cards. How much information did you receive if the card was a spade, or the card was an ace, or the card was an ace of spades? You can immediately find out that spades are more in number, aces are less in number, ace of a spade is only one, right? So Naturally, the ace of spades is going to contain a largest amount of information, and the spade which you are going to draw is going to get a less amount of information. In between, there is this ace. Okay. So, let me show you. See, P of spade is 13 out of 52, which means there are 13 spades in a deck of cards. There are only 4 aces in a deck of cards, whereas there is only one ace of spade. So, probability of spade is 13 by 52. Probability of ace is 4 by 52. Probability of the ace of spade is 1 by 52. Now, let us find out I of M1. I of M1 is minus of LG 13 by 52. I am going to use this symbol LG. LG means log to the base 2. Whenever we use log to the base E, we use the symbol Ln. Whenever we use log to the base 10, we use the symbol Log. Whenever we use log to the base 2, we use the symbol Lg, just for the sake of simplicity. So, this is minus of Lg 13 over 52. Why I have written directly? It has to be Lg of 52 over 13. It is 1 over P, right? We can also write it this way. We can directly write minus of Lg of P itself. So, when you calculate this in the calculator, you can find out 13 by 52, take its log to the base 2, and that will already come as minus symbol. And you add one more minus. Whenever you take a log between 0 and 1, you will get a minus symbol naturally, right? Because it is not having integer, it is having a fraction. Always the log of the fractions, you are going to get a negative number. That is when I showed you the 3 properties, where it is between 0 and 1. So, when you take the log of this fraction, you will get a negative number. Minus and minus becomes plus. So, I of M1, we can say the information contained is 2 bits. Why I am saying bits? Because we are using log to the base 2. We are not using a nat or decit. Similarly, I of M2 is minus of Lg of 4 by 52, or you can write it as Lg of 1 over 52 by 4 also. Lg of 1 over this P of ace. You can write it that way. It comes out the same. This is now 3.7 bits. Now, I of M3 is minus of Lg of 1 over 52 is 5.7 bits. Now, you can see whichever is having a lesser probability is having more amount of information, and the information is measurable. We measure information now in terms of bits only. So, I of M1 is 2 bits, I of M2 is 3.7 bits, and I of M3 is 5.7 bits. Okay. Note that I of M3 is equal to I of M1 plus I of M2. Just look at this. 5.7 is nothing but 3.7 plus 2. Why? It is ace of spade. We found out the information of spade. We found out the information of ace. Now, the ace of spade is nothing but the summation. Just recall whatever I discussed earlier. I of M1 into M2 equals I of M1 plus I of M2, because it is a logarithmic function. So, it is proved here. In this example, it is proved that I of M3 is I of M1 plus I of M2. Let me proceed. We commonly use, I keep on writing this note so that you will keep on recalling whatever notations we are using. We commonly use log to the base 2 of M for measuring the information content, because we are going to use digital channels and we are going to transmit digital information only. Almost all of our communication nowadays is happening in the digital fashion. So, naturally, we will be using log to the base 2 only, but we will be discussing log to the base E, log to the base 10 only for the sake of history, or only for the sake of comparison. Now, the symbols for the logarithms are: to the base 10 is common logarithm log, to the base E natural logarithm ln or lan, to the base 2 is binary or Lg. I keep pronouncing it as Lg only. Now, let us see one more example. In the next class, I am going to give you some exercises you have to work out on your own. In today's class, now in this particular class, I am going to show you these exercises. In the 5th hour, it is highly probable that I will take the 5th hour, okay? So, when I take class in the 5th hour, Be ready with your calculator, with your notebook and pen. I'm going to give you some exercises. Let us see the next exercise. A pair of dice is tossed simultaneously with outcomes as x1 and x2. A dice has got now 6 faces. Two events are defined as A equals x1 plus x2 is less than or equal to 7. Means when you toss the dice twice, there will be 2 faces there. Now, the sum of those 2 faces will be less than or equal to 7. And B equals x1 greater than x2 means when you toss the dice first time and when you toss the dice second time, the face which is occurring for the first time will have more number of dots than the second toss. Now these are called 2 events. Both are possible. Actually there are many events possible. Here in this exercise only 2 events are defined. Otherwise so many such events are possible. When you just toss the dice twice, depending upon the face which you are seeing on the dice, you can establish a lot of other relationships between the first event and the second event. There can be many mathematical relationships. All of these mathematical relationships are events. Here in this exercise, we are discussing about only 2 events. Now, the question is, out of these 2 events, which one conveys more information? Is the task here. That means, if A is lesser probable than B, then we should say A is containing more information. On the contrary, if B is lesser probable than A, then we should say B is containing more information. But we will have to work this out now. We cannot have a random guess here. We will have to work this out. Let us say, we have to write a sample space now for the tossing. Now this is a sample space where a matrix is written, where you can see first one is 1 and 1, then 1 and 2, then 1 and 3, then 1 and 4, then 1 and 5, then 1 and 6, x1 and x2. Similarly, 2 and 1, 2 and 2, 2 and 3, 2 and 4, like that it goes on till 6 and 6. Now each one is x1 and x2. There are these many combinations now. There are 36 combinations possible. 6 into 6 is totally 36. 36 combinations are possible with these 2 tosses. Now this is the sample space. In this sample space, we have to find out those particular samples which are relevant to A and which are relevant to B. Now, out of these 36 entries, A has got 6 plus 5 plus 4 plus 3 plus 2 plus 1 equals there are totally 21 events which are satisfying A. Why? x1 plus x2 less than or equal to 7. You can see here 6 plus 1 is 7, 5 plus 1 is 6. So these 2 are matching. 6 plus 2, 5 plus 2, 4 plus 2, these are matching. 6 plus 3, 5 plus 3, 4 plus 3, 3 plus 3. Similarly here till 4 plus 2. Here it is till 5 plus 1. Here it is all of them. So there are totally 6, 5, 4, 3, 2. That way it goes on. 6, 5, 4, 3, 2, 1. And there are totally 21 entries now. Okay. Whereas B has got 1 plus 2 plus 3 plus 4 plus 5. What is B? X1 must be greater than X2. Now here X1 is greater than X2 is happening here in 6, 5, 6, 4, 6, 3 like that. Again here you can have only 1 plus 2 plus 3 plus 4 for 5. So that way it goes on. You can check that. Here X is greater than X1 is greater than X2. In this case in the third row 3, 1, 3, 2. So 3, 1 and 3, 2 that is matching with B. That way A has got 21, B has got 15. Totally I of A is minus of LG or 21 by 36 is 0.778 bits per symbol. And I of B is minus of LG of 15 by 36 is 1.263 bits per symbol. So event A contains more amount of information because event A is less probable. What is it? X1 plus X2 is having less than or equal to 7 is less probable than X1 being greater than X2. Okay. So that way, sorry, I think I told the reverse. I of B is larger. Actually, x1 remaining larger than x2 is less probable. We already see this probability. A is 21 by 36, B is 15 by 36. So B is less probable. Which one is lesser probable? Is containing large amount of information. So that way event B is containing more information than event A, because event B is less probable. Last 5 minutes. There is a relationship between Hartley's, Nats and bits. Hartley is nothing but decit. Log to the base 10, log to the base e, and log to the base 2. We can derive this relationship. I equals log of 1 over p Hartley. Let us say we take common logarithm. Now that is ln of 1 over p nat. If we take natural logarithm, it is lg of 1 over p bit. So we can write as 1 Hartley equals I by log of 1 over p. Using the same equation, 1 Hartley keep it at the RHS, bring it to the LHS. 1 Hartley is I of log of 1 over p. This is nothing but ln of 1 over p by log of 1 over p nat. That is the relation between natural log and common log. So we can say 1 Hartley equals, simplifying this expression, log of 1 over p divided by log to the base e, log of e to the base 10. Sorry, it is not log to the base, log of e to the base 10 and log of 1 over p. Now 1 Hartley is 1 by log of e nat. 1 by log of e is nothing but 0.4343. So 1 Hartley is nothing but 1 by 0.4343, or 1 Hartley is 2.303 nats. Or we can say 1 decit is 2.303 nats. Similarly, we can find out the relationship between Hartley and bits. We know that 1 Hartley is I by log of 1 by p, that is lg of 1 by p by log of 1 by p by the common logarithms relationship. Or 1 Hartley equals log of 1 by p divided by log 2 divided by log of 1 by p. We get like this: 1 Hartley equals 1 by log 2 to the base 10 bit. Log 2 is nothing but 1 by 0.3010, or 1 Hartley equals 3.322 bits. So, see, 1 decit is 2.303 nats, 1 decit is 3.322 bits. Why? Because bits is only 2 bits, whereas the value of e is larger than 2 and the value of 10 is larger than e. That is how we get this relationship, where 1 decit or 1 Hartley is 2.303 nats and 1 decit or 1 Hartley is 3.322 bits. So we can always find out 1 nat is nothing but 3.322 divided by 2.303 is nothing but 1.422 bits. Because we know that 1 Hartley is 2.303 nat, 1 Hartley is 3.322 bits. We want to establish the relationship between nat and bit. By means of this, we can find out 1 nat is 1.442 bits. Now remember this particular derivation. This is an important derivation. It's a simple derivation, but it's important we keep on asking it in test also and in exams also, because students have to remember these relationships. With this, I'll end the class now. See you again, most probably in the 5th hour. Okay, bye-bye.